Hello, welcome to another video by LSX Engines, Tuning, and Marine. This video is part 2 of a playlist called Mercruiser 5.7 Engine Installation A to Z. And it's been 2 days since I last did a video on this particular segment. And the reason is I ran into a little snag with the spark plugs. I want to cover that here because I created another video series on that, which I'll put a link to that video in the description of this video. I don't want to take up time on this video discussing what the problem was and how I resolved it. So I'll just refer you to go watch that video if you want to see what the problem was. But at this time, I've just got the plugs installed, and since the last video, I've installed the carburetor. I've installed this heat crossover. When I first took this engine apart or out of the boat, I thought that was a water passage from the exhaust over into the intake as a loop, but at the time I didn't think that was correct, because if you have water short-circuiting your thermostat, your engine may never heat up. So it turns out it's not water, it's exhaust gas, and the exhaust goes off your exhaust manifold over into a cavity inside the intake manifold under the carburetor. Not sure how great that works, because if there's no way for that exhaust gas, once it goes in, to get out, it's going to hit a dead end and it's not going to flow very well. So my thinking was there might be a little tiny pinhole in there to let some of that exhaust gas go into the engine and get burned, not burned, but go into the engine and get recycled again. But I couldn't find, I put pressure on that outlet, or on that fitting, and I could not find, it didn't leak anywhere. So I guess they're just relying on straight up convection to, not convection, but I don't know how it works, to be honest with you. You need flow of the heat to flow from there into there, or flow of actual exhaust gas, in my opinion, to make this thing heat up. But somehow they made it work. But anyway, I'll figure that out later. So I've installed that tube there. It was kind of a pain in the tail. Put the carburetor on. I have not hooked up the harness to the carburetor yet. There's actually an electric choke here. I have not hooked that up yet. I need to do that next. But anyway, the plugs are in it at this time. The exhaust is all hooked up. By the way, I didn't discuss before, but these rubber hoses that come off the thermostat housing go around, come underneath, and they attach right down there. That's the that's the port side, and then the same thing on the starboard side. So all the hoses, and I tightened the pipe clamp. So all the hoses are done now. Next, I'm about to put the distributor cap on and route the wires to the appropriate spark plug, and I'll show you how to do that, because that's something very important you need to know how to do. So, and by the way, when I put this distributor in, I looked at the cap. This is the cap right here, and the cap told me which one was number 1. Let me see if we can find it here. There it is right there. So if you look right down through there, you see number 1 right there. Number 1 right down there, tip of my fingernail. That's number 1. So this is the spark plug wire that goes on number 1 spark plug. And that's because when I put the distributor in, I had the rotor lined up to this point when the engine was at top dead center and the firing stroke on the number 1 cylinder, which is the front right cylinder, or the front port cylinder on this engine. So when you put these spark plugs, these wires in, this is number 1. The firing order is 1, 8, 4, 3, 6, 5, 7, 2. So you just route your wires to the appropriate spark plug based on the rotation of this distributor in a clockwise fashion. Like I said, it's 1, 8, 4, 3, 6, 5, 7, 2. All right. So in the cylinder orders on your engine, I'm starting with the port side first. It's 1, the odd cylinders on this side, 1, 3, 5, 7. Over here it's 2, 4, 6, 8. So like I said, you follow the spark plug cap and the wiring in the order I just mentioned, and you just run the spark plug wires to the appropriate number cylinder, and then you hook them up. Then you screw the cap down, and the distributor will be installed. Then now the plugs are in, and I'm going to put a little bit more oil in this thing. I think I put 3 quarts to start, just to build up pressure, but I checked the dipstick and I did not have any oil show on the dipstick, so I'm going to keep putting oil in it until I have some show up on the dipstick before I even try to fire this thing up. Once the distributor cap's on, the next thing to do is hook up. This is your trigger wires here, coming off your distributor right here. They go to these two I discussed before. Once those are hooked up and the distributor cap's on, all the spark plug wires are run. I'm going to turn it over to key just to see if it turns over one last time. And well, I want to make sure the battery's strong enough to turn it over with compression with spark plugs in it. And if it turns over, I'm going to pour a little bit of gas in here and turn it over and see if it runs just on poured gas. I have not connected the fuel pump yet. One of the things one of my I won't call it cardinal rules, but fundamental concepts that I'm doing lately is methodical approaches to things. I'm trying to do one thing at a time and not do multiple things at a time and get ahead of myself. If I were to hook up this fuel pump and try to fire it up, it might overflow the engine with gas like it did once before. I'm not going to take that chance. There's other things that can go wrong. I don't know off the top of my head what they are, but well, I could have electrical spark and next thing I know I've got a fire. Who knows? But I'm just doing things one at a time, make sure each step that I do works before I proceed to the next step. And there's something, I've got a big surprise coming probably in about a month or two that I'll hope everybody sees, and then you'll understand how far I'm carrying this methodical concept. All right, so I'm going to stop the camera now, put the distributor cap on, and crank this thing over without gas and just see if it turns over. All right, here we go. Turning the key to see if we can get this engine to turn over. Let's see if I got it moving on my gauges. Yep, gauges move, so I know we got power up here. So here we go. Apparently don't have enough battery. Yep, battery's not strong enough. I have another battery I can hook up to it. So it's about 10 p.m. So I'm going to stop for the night and start over with this thing tomorrow. All right, it is now Saturday, 1 week after I've started this video series, boat engine installation A to Z. And so far I've had 2 complications, and I'm working on the third. These complications are killing my productivity, and it seems to happen on every boat. I guess it's just the nature of the business, but I'm going to do what I can to eliminate these kind of problems in the future. But so obviously the first complication I already discussed, it was the spark plugs wouldn't fit because these new manifolds were interfering with their with the tool, putting them in the hole. So got that resolved. So where I left off the last segment was I tried to turn this thing over and all I heard was clicking. And so those are the customer's batteries. I bypassed those. I put on my own brand new battery, and it was still just clicking, or it wasn't even clicking. Well, there was a click, but it wasn't a very loud click. So I had my son come out and turn the key on to start, and I could feel this solenoid here clicking. The solenoid was just a relay, and I could hear this thing clicking, but it was not turning the motor over. So fortunately, O'Reilly's Auto Parts has a marine section. And they had a new solenoid just like the one I took out. This is the one I took out, and that's the brand new one, and it's identical. So if you run out, you need a starter solenoid, check with O'Reilly's. I may have a marine solenoid. So let me explain how this works. So there's actually, on a boat, there's actually 2 solenoids. On a car, you typically might have just one solenoid where ignition switch turns on the solenoid, which engages your starter and starts the car. Let me back up. In case you don't know what a solenoid is, solenoid is basically an electromechanical magnet. So when you apply, these are the 2 low current devices, or low current connections over here. When you have 12 volts here, it energizes a coil of wire inside, which creates a magnet, which pulls a bigger contactor to make these 2 inside touch. This one and that one touch inside. And then this wire goes down to the starter, which engages another solenoid just like this, but bigger. And that actually mechanically engages the starter gear with the engine, and then it turns the engine over. The reason on boats I have 2 of them is that the circuit that feeds ultimately feeds the starter solenoid goes from the starter down there where the battery's connected up through that boat harness, goes all the way to the front of the console up there in the front of the boat, goes to the ignition switch. So I think it's a purple wire. Goes to your ignition switch, and then when you turn the ignition switch on, you bring, at least to the start position, you bring start power back to this terminal right here. this back one here, that's ground, and this is 12 volts only when the key is in the start position. When it hits start, it energizes this. This terminal here is battery power. It's hot all the time, 12 volts. I believe it runs through this 50 amp breaker. I could be wrong, but I believe it runs through that 50 amp breaker right there. So, or I could be wrong. There's a fuse down there on the starter. I think it's a 50 amp fuse also. This might just be for your trim tilt. I'll check into that. But anyway, so this will have 12 volts on it all the time, whether it goes to whichever fuse or the circuit breaker, not sure. 12 volts all the time. When you engage this with the starter, the key switch and start, it engages this side. This wire runs down to your starter. So that's what makes your engine turn over. So, as you'll see later, if what I'm about to do doesn't work, you can also get what's called a remote start switch. It's just a little push button with 2 alligator clips. You can clip the alligator clip here and there, hit your button, and you'll bypass the starter solenoid, and you'll apply volts directly to your starter, and you can remote start or you start the engine without the key. Or let me rephrase it, you can turn the motor over without the key. Whether it starts or not, it's a different story. I'll get into that later. So, obviously, to work on boats, you need to understand how to rebuild motors mechanically, which you also you need to understand some electrical, have some electrical knowledge also, which I've done electrical work and mechanical work before. That's the second complication. I said the spark plugs is the first one. This solenoid was the second one, which I replaced not last night, 2 nights ago, and now I'm on my third complication. And this seems to bite me in the butt every time. So after I replaced the solenoid, I finally got it. It would turn over. The engine would turn over on this battery with the key. And so what I did is I poured a little bit of gas in this carburetor, and it would not fire. Would not fire at all. So I then pulled the center lead off the distributor cap, stuck a spark plug in there, and actually I stuck this device. This is a spark plug testing tool, which you saw in one of my other videos. So I hook the let's see here, hook this into the spark plug wire, and take this alligator clip, this end, and just attach it to ground somewhere, and then I set my gap in there. You don't want to have them touching. You can see that's touching right there, and I have to back that out. But you want to put a little gap in there, and then you can set this over there, and especially in the dark, you can see it really well if it's sparking. So again, this is the Thunderbolt, Mercruiser Thunderbolt ignition, Thunderbolt 5, and I had a spark coming from the coil on this wire right here. This wire had a spark coming to here on this wire. But then when I connected it to the distributor, I had no spark at my spark plugs out at the cylinder number 1. So I either have and I doubt if I had one bad wire, because if it was just one bad wire, it would have fired on the other 7. So, I'm gonna have to go back to basics and start checking things. So, what I'm going to do is, first of all, make sure that I have my distributor statically timed, which I'm 99% sure it is, because I remember doing it. But I'm going to double check that. So let me explain how I'm going to do that. So in order to check the distributor static timing, which means you're trying to check to see if the rotor is pointing at the right distributor cap when the number 1 cylinder is at the right location, I've got to set this engine back to top dead center number 1 I'm going to turn the front pulley down here, turn it manually until my timing marks line up to 0 for number 1 cylinder on the compression stroke. So with everything buttoned up, how do I find out if it's on a compression stroke? Well, one way is to take the number 1 spark plug out, and you put your finger in the hole, and then you got to turn it over. You got to maybe have an extra helper person. I'm by myself today. My son, who's a Georgia Bulldogs fan, bailed out on me to watch Georgia Bulldogs on an 80-inch big screen TV. I don't blame him. I feel like I ought to be there too. But anyway, I'm not a Georgia fan, so I'm not there. So so at this time, in order to find out where the engine's at, what you can do, you can look through these holes here. If I pull this hose out, that won't help because there's a metal baffle inside there that will not let me see the rock arms. Same with this hole back here. This hole here is a baffle, can't see the rock arms. However, this hole back here, which I have the oil field cap, if I pull that oil field cap out, I can see a rock arm in there. I believe it's number 7 intake. I'm going to verify that, but I believe that's what it is. Matter of fact, let me see if I feel it. So I feel number 7 there. I'll have to do this off camera, but once I determine, I'm pretty sure that's 7 intake. So knowing the firing order of this engine, which is 18437, let's say 18436 5.7.2. So 7, 2, then 1. When you get to 2, it starts over at 1. So the way this engine works is that, so if number 7, if I see that intake valve moving on number 7, that means the piston has already come to the top. It's in transition. It's come to the top. Let's see, let me turn the camera, brother. Let me see. So piston's come to the top, and now it's starting to come down, and your intake valve opens. So I know 7 is halfway down. Number 2, which is right after 7, will be at the top. It'll be at top dead center, because these cylinders are not, it's a V8, so everything's 90 degrees apart. So number 7 will be halfway down, number 2 will be at the top, and number 1 will be halfway down coming up. So once I see number 7 rocking or moving, I'll know down here to look for that time mark to be on number 1 in approximately a little bit less than 90 degrees. 90 degrees of rotation of the engine will put number 1 at top dead center. But because number 7's rocking, it'll be number 1 is rocking, and it will be on the transition side, not compression. So once I find number 1 on transition, once I find the 0 mark on number 1 at transition, I then need to rotate it another 300 full turn, 360 degrees, and I'll be at number 1 on compression. So if you're by yourself and you don't have a way of putting your finger in the number 1 hole to find out where it is and see if it's on compression, this is an alternative method. So that's what I'm going to do. I've got a torque wrench and a socket. I'm going to put it on this 5/8 socket on the front of the motor. I'm going to turn the motor by hand, and I'm going to watch for that rocker to be moving. Once it's moving, I know that I should find number 1. Let's see, timing mark is right down there. I don't know if you can see it. Let's see, there's a little notch at the tip of my finger. That notch is plastic on the plastic timing cover, and there'll be a mark on the harmonic balancer to line up with that notch at 0. When I get it to 0 on number 1 in transition, I then need to go another full 360 to be at compression. Okay, I've now done what I said I was going to do. I saw the number 7 intake moving, and I rotated around until I had the marks. That wasn't top dead center. I know it was close. It didn't matter because I had to go around another 360 anyway. So I've come around another 360, and I can't see the mark because of the daylight and the sun. I can't see down there very clear enough to see what the mark is. So this would be a good time to introduce complication number 4. So number 4 is that this water pump, you hear the bearing is shot inside. So I've already told the customer I was going to replace the water pump, and now as good a time as any. If I get this water pump out of the way, I'll be able to see these timing marks a whole lot better. So I'm going to go ahead and pull the water pump off so I can see the timing marks and check my distributor. That's complication number 4. It's kind of my stupidity. I should never put it on. I thought maybe if I put it on and got water running through it, they would clear up. But I put some WD-40 down in this hole, and it helped a little bit, but it's not going to make it any better. So this water pump's got to go. I've already got one to replace it with, so I'm going to go ahead and remove the water pump now. Alright, as I was saying, I've now removed the water pump, and I can now see the marks clearly. So this long mark is your top dead center mark. When it lines up with that notch, that's top dead center. And so as you can see, I've got it at top dead center. And what I did, oh, by the way, if you work on boats, you need one of these tools. This is a grabber. It's about 2 feet long, and has this claw on the end of it. And if you drop something down in the bilge, you can get it out with this a lot easier than crawling down there and reaching for it with your hand. So this is a very handy tool. It's almost a must-have to work on boats. So anyway, what I did was I reached back there and I clipped it onto that rocker, that number 7 intake rocker, and just let it sit there. And as I rotated the engine over, as soon as that moved, I saw this thing move, and that told me that number 7 was intake was starting to open, which means 7's coming down, 2 is almost to the top, and 1 is 90 degrees away. So after I saw it move, I rotated this mark till it was this location at top dead center, and then I went around another full turn to get it to right here. So that's where I'm at. So at this time, I'm going to take the distributor cap off and see where my rotor's pointing. It should be pointing right here. This is my number 1 cylinder. You can see that 1 right down there. There's the 1, there's your 2 over there. Remember the firing order is 1, 8, 4. So the cap is labeled for you. 1, 8, 4. There's the 4, and then it goes around. So this is 1 right here. So the rotor inside should point to this tower top dead center on number 1 for what's called static timing. That's just a base initial timing to get your engine started. Once it starts and runs, then you can adjust it with the timing light to get it right on the number. So, and I'll show you how to do that once I'm check this out. The entire reason I'm doing this is just to go back to basics. I'm 99% sure it's right, but anytime you have a problem, if you don't start with the basics, you'll be wasting time chasing your tail because you messed up from the start, and everything you do from that point on is wrong. So it's very simple for me to take this cap off and check it to make sure. Yeah, it takes me 10 minutes, but it's worth an extra 10 minutes to make sure I'm starting from the right location. All right, I now have the distributor cap loosened, and I'm going to take it off and show you where we're at. So this is number 1 right here. That rotor needs to point right here if this thing's correctly timed. So if we lift the distributor cap off, there it is. So there's number 1. It's actually slightly retarded. I need to, let me think about this. No, it's actually advanced. Okay, so anyway, the bottom line is it's pointing in the proximal location. It's pointing right there. I'm going to loosen the distributor and move it around to where it points right at this tower, so I know it's timed right on 0. At least I know it should start right there, and then I'll deal with the advance later. But I'm going to get this distributor pointed right at the proper cap. It should run where it's at, but just to be sure it's safe and just to be sure, I'm going to rotate the distributor just a little bit. I'm going to rotate the distributor clockwise so that the cap moves around to where I want this cap to move around to right there where the rotor's pointing. All right, what I've done, I loosened this bolt right here a little bit. Well, I didn't tighten it very much to start with, but I loosened it a little bit. And then I rotated the distributor base, not the cap, but I rotated the base until the rotor points right here at this tower right here. So if we lift this up, you can see the rotor's pointing right there. All right, so now this is timed for pretty much 0 degrees. 0 degrees top dead center after top dead center, after top dead center, doesn't matter once it's 0. It's the same thing. So now I'm going to tighten the distributor back down and put a new water pump on this engine. And actually I'm going to take some white paint and paint this thing at 8 degrees. That's supposed to be the initial timing on a Mercruiser 5.7, I believe, with Thunderbolt. I'm going to put me a white mark on 8 degrees before I put the water pump back on so I can see what I'm doing. So, as I was saying before, one of the reasons one of the benefits of taking this water pump off and replacing it was I now have access to these timing marks. So I'm going to take a piece of, I'm going to paint a white mark on the 8 degree mark on this balancer so I can see it with the timing light much better. Incidentally, or by the way, these are Q-tips. I buy them like, I don't know, 100, 500 to a box for, I don't know, $3, I don't know. They make great little paint brushes. So I just spray the tip with white paint. I get this Rust-Oleum gloss enamel, gloss white, and I'm going to spray the tip of this Q-tip and then brush on white paint on the 8 degree mark. The 8 degree mark, each one of these notches is 2 degrees. So there's 2, 4, 6, 8 right in there. So about to put a white mark there on the 8 degree mark, and then I'll be able to see it with the timing light. All right, I've now painted a white mark on the 8 degree mark. It's actually just a slight bit to the right of 8, so I'd say maybe 9, but it's close enough. So I can now put the water pump back on and then try to get this motor running. So before I put the water pump on, I have to scrape this old gasket off this side of the block and off that side of the block, and then I can put it together. All right, I'm now prepping another used water pump that is in good shape. It came off another boat, or it came off of another project I had left over, and it's in very good shape. No squeaking, bearings feel fine, seal feels good. I just want to show it's identical to the one, or close enough to this one's coming off of it. It's the same height, pulley wise. Pulleys are the same height, everything looks the same. Same shape, same bolt pattern, so it's good to go. So I'm going to transfer the water hose to this pump, clean off the gasket surfaces, and mount it on the engine. All right, the replacement water pump is now prepped. I've transferred the hose over to this replacement, put the serpentine belt pulley on here. Spins free, no problem. And this is the old one that's going in the scrap yard. I haven't tightened this up super tight yet because I'm going to tighten it up when I get in the boat once I get this hooked back up. And about ready to put it on. So I've scrape the old gasket material off the surfaces, and it's ready to install. Now I've got to scrape the block off, put 2 gaskets on it with silicone sealant, and put the water pump on. Alright, I'm now putting the water pump on and tightening the bolts. And on water pump bolts, I don't use blue Loctite. I use the gray silicone sealant on the threads to help seal it, because these bolt threads go into the water jacket of the block, and it helps keep water from leaking out around the bolts. Blue Loctite might work, I don't know. I've just always used silicone instead. So I'm about to put this bolt goes right down there, and then do the bottom bolt, put silicone on the bottom bolts, and tighten this water pump bolt. The gaskets are installed. Both sides have gray silicone sealant. Alright, the new water pump, or the new improved water pump, is installed. No more squeaking, real smooth. Got gray silicone sealant on all the bolts, 4 bolts. The 2 with studs on them are on the top, and then the long one goes there, and the medium one goes there. Water pump's installed. I have a white mark on my timing mark now. And so now I can proceed to, well, I gotta put this, I had to put this idler pulley, this is an idler pulley bracket for the serpentine belt. I had to put that back on first. It won't take just about a minute or so. And I am gonna use blue Loctite on the bolts that hold this on, because they don't go in the water jacket. And once I get that done, I'm gonna see if I can get this engine started on gasoline, by pouring gasoline in the carburetor. I'm not gonna hook up the fuel pump until this thing, I know it's gonna fire and ready to go. Alright, the serpentine belt idler pulley bracket's now installed, and I'm not going to put the belt on until this engine's running and ready to go. I may run it no more than 5-10 seconds without the serpentine belt on it. I'm now going to tighten the distributor cap back down, put it on, and then put a little gas in the carburetor. I'm going to take the air cleaner off, get it out of the way, pour a little gas in the carburetor, and see if I can fire this thing up just on gasoline poured in the carb. By the way, in case you don't have one thing that's very handy in tight quarters is a universal joint for your socket. This is a 3/8" drive universal joint, and that makes using the impact driver a lot easier in some of these tight quarters. And it's a very, very useful tool, indispensable in my opinion. So it's another must-have tool.